So this video is all about multiplying decimals. And to talk about multiplying decimals, we're going to look at what we know about multiplying whole numbers, and then we're going to go through the difference between whole numbers and decimals in terms of that decimal point and how we convert between. And that's going to help us figure out what it is that we're going to do with that decimal point when it comes to multiplying. So the first thing we're going to do is we're going to look at an example of a problem that you've had some experience looking at before you got into 6th grade, 34 times 26. If you want to go ahead and pause the video and do this problem as practice, because we'll get to a similar problem to this a little bit later, and it'll help to have this practice problem, go ahead, pause the video now, and come back when you are ready to move on. So when we're going through the problem of 34 times 26, I'll take you through the process this one time at the beginning of the video, but if you do have questions about the process of multiplying integers when they have more than 2 digits or even more than 1 digit, you're going to go back to a section of the Haiku page called Review Videos Before 6th Grade, and you're going to watch the video on multiplying whole numbers. But 6 times 4 is 24, 6 times 3 is 18, plus 2 is 20. We're moving over by 1 digit, so we add a 0. 2 times 4 is 8, and 2 times 3 is 6, so we add them together. Get 884. Great. That's how we add, or not how we add, rather. That's how we multiply integers. Remember that every time we move from one place to another, we have to add that placeholder 0 because, after all, the 2 doesn't mean 2, the 2 means 20. When we're multiplying by 20, we have another 0 at the end. But so how is this related to something like 34 times 2.6? And in order to talk about 34 times 2 and 6/10, we have to ask ourselves the difference between 24 and, or rather 26 and 2.6. How do the two of them compare? And the shortest way to get from 26 to 2.6 is to divide by 10. And we divide something by 10, the decimal point moves one place to the left. And that's how we have a shortcut with multiplying and dividing by 10, as you're probably aware and saw in lower school. So this idea that 26 is related to 2.6 simply by dividing by 10, and by dividing by 10 we move the decimal point one place to the left, by dividing by 10 once, is going to be what helps us figure out where our decimal point goes when it comes to multiplying decimals. Because the process of multiplication itself is identical to multiplying just regular whole numbers, but when we have the decimal points, we have to add one extra step at the end. Otherwise, it's essentially the entire thing is the same. So 34 times 2.6 compared to 34 times 26. 34 times 26 is 884, as we saw before. Now 34 times 2.6 is very much like 34 times 26, except 26 divided by 10 is 2.6. So in that case, we just need to divide our product by 10, and we will end up with the product that we want for 34 times 2.6. Another way that we look at it is that because the difference between 26 and 2.6 is that we have one decimal place, which is divided by 10, we have to include one decimal place in the product in order to make that work. So a few things about multiplying decimals that we need to talk about, and I will tell you when to pause the video and write down this process, and then we'll go through a few example problems. The first is that multiplication with decimals follows the exact same procedure as multiplication with whole numbers. We don't bother lining up the decimal point, we just set up the multiplication problem. Now you can always line up the decimal point if you really want to, but that's going to result in a process where you have lots more numbers to multiply, lots more decimal places to work with, and that is totally fine. The process does work that way, but it just adds a few more steps. So if we want to get to it from factors to product in the most efficient way possible, we don't line it up. In class, we'll talk about how we adjust when we do line it up. In the video, we're not going to. So first, we don't bother lining up the decimal point. We just set up the subtraction problem. And it's going to be set up exactly like the problem that we said before. This decimal point doesn't represent a digit. It is just a decimal point. It is indication of changing place values. We're going to actually do the multiplication to get to 884 as our digits from left to right, and then we use as many decimal places as we see in the numbers above. There are 0 decimal places in 34. There is 1 decimal place in 2.6. Therefore, we have 1 decimal place from the right in our product, and it is 88.4. So I'm going to ask you to go ahead and pause the video here. Here are the things that you're going to write down. You're going to write down, we don't bother lining up the decimal point, we just set up a multiplication problem. You're going to write this entire example problem here, including the indications of now use as many decimal places as the number above, the 1 place up here on the right, and the 1 place down here on the right. So go ahead, pause the video, copy those down. We're going to go through an example problem to make sure that we've got it, and then we'll have 4 problems for you to work on at the end. So go ahead, pause the video, come back when you're ready to move on. So let's look at an example then. Let's take the example of 12.4 times 2.5. Now, I always recommend that you put the larger number on top. And I said larger and not greater because by larger, what I mean is the number with more digits that are not 0. We could have a really long decimal with 12 zeros in front of it and only 2 digits. Those are the only two interesting digits that we have to worry about multiplying. We need to worry about the decimal places. But 12.4 has 1 more digit than 2.5. So if we put it on the top, we have less rows to worry about in the multiplication underneath. So this will be the last problem that I actually go through the multiplication steps for. Otherwise, I will give you the product in terms of just the digits, and then we'll adjust for the decimal place, but I will take you through this problem from start to finish. 5 times 4 is 20. Carry the 2. 5 times 2 is 10, plus 2 is 12. Carry the 1. 5 plus 1 is 5, plus 1 is 6. Add a 0 as a placeholder because we're moving from the 5 to the 2. 2 times 4 is 8. 2 times 2 is 4. And 2 times 1 is 2, giving us an eventual product of 3100. Now when it comes to our decimal points, we have 1 in the first factor, we have 1 in the second factor, so therefore we need to have 2 decimal places in the product to get 31 as our eventual product. Why? It's because comparing 12.4 to 124, we divide by 10 or move the decimal point 1 place. Comparing 2.5 to 25, we divide by 10 and move the decimal 1 place. And since we do that twice for our factors, we do that twice in our products. Now here are 2 pages of 2 problems each for you to work on. So I'm going to ask you to pause the video and work on these twice. Go ahead, pause the video, work on these 2 problems. As I said, I'm not going to give you the full multiplication process. I'm going to give you the digits of the product, and then finally how to adjust the decimal point. So go ahead, pause the video, work on these problems, and come back when you are ready. So for the one on the left, 3.14 times 28, the digits you should arrive at in your product from left to right are 8, 7, 9, and 2. Now, our first factor has 2 decimal places. Our second factor has 0, so our product should have 2 from the right. 1, 2 decimal places, to give a product of 87.92. For the problem on the right, 0.14 times 0.09, that product gives us 126 from left to right. And there are 2 decimal places in the first factor, 2 decimal places in the second factor, so therefore we have 4 decimal places total in the product. And so we need to move from left to right over 4 places. We move 1, 2, 3, and then we have to move 1 more place because it says we move 4, so we have to place a 0 because we've run out of digits and we need to move 4 over in order to have the correct number of decimal places in our product. This is 0.0126. If you run out of digits before you've reached the number of places you move, you have to add some zeros on the left. Last 2 problems, go ahead, pause the video, work on these, and come back when you are ready to move on. Now 25 times 0.0025 gives you the digits 625. We have 0 decimal places here and 4 in the second factor, so we have 4 in total in the product. 1, 2, 3, and again add one more decimal place to get 0.0625. And when we look at the problem on the right, 16.34 times 1.001, the digits we get are 1636635. Now we'll talk about a little about this and about how many zeros we need to move over as we're going through the multiplication tomorrow, or you can go back to that before 6th grade review video, like I mentioned at the beginning. We have, in terms of decimal places, 2 in the first factor, 3 in the second factor, so 1, 2, 3, 4, 5 in the product. 16.36635, or more properly using place value, 16 and 36,635 hundred thousandths. So again, when we're multiplying decimals, we don't bother lining up the decimal points. We just set it up like a multiplication problem and multiply, and the number of decimal places from the right in the product is the same as the sum of the decimal places in the factors. However many you have in the first factor plus however many we have in the second is the number that we're going to have moving from the right in the product.